Hello viewers, today in this video I will show you how to overcome the shortage of analog pins in Node MCU. Without using any analog multiplexer, we can handle projects having sensors without using analog pins. A whole range of sensors uses analog pins to send data to the microcontroller. Now the most popular Arduino Uno has 6 analog pins. Though smaller, the Arduino Nano has 8 analog pins. And these numbers are sufficient for most projects, but the ESP8266 comes with only single analog input pin. Now, one way to solve this limitation is to use analog multiplexer, which gives 16 or more number of analog pins. But in this particular video, we will learn to solve the problem without using a multiplexer. Let's consider a particular case. We have two potentiometers and we want to read the values of them separately using the single available analog pin. This potentiometer have 3 pins. One is ground, VCC, and the wiper or the output pin. One simple way to solve this problem is to switching the VCC pins of the potentiometer using 2 digital I/O pin of the microcontroller. Note that we have connected wiper pin or the output pin of both the potentiometer to the A0 pin. So, how can we get readings of 2 wipers separately? As I said, we connected the VCC pin of the 2 potentiometer to 2 different digital output pin D3 and D4 of the microcontroller. And by this, we are able to power on and off those potentiometers separately. Now, say we want to read the value of the first potentiometer, then we will turn digital output pin D3 high and D4 to low. Thus, we will only get the value of the first potentiometer to A0 pin. Then, if we want the value of the second potentiometer, we will have to put D3 to low and D4 to high. So now we are able to get separate readings only using a single analog pin. This solution works because the microcontroller can do those switchings fast enough, and finally it seems to be simultaneous reading of 2 potentiometers separately. And this solution with powering just only one sensor at a time and reading its value and doing the same for the rest of the sensor can be extended as long as we have available digital output pins. Very often we are to connect joystick module to control robot cars. And if we have the joystick in a module form, the previous solution fails. Because we have the ground and VCC pins of the joystick's potentiometer hooked up parallelly. So there's no way to power 2 onboard potentiometers separately unless we desolder it and make custom wiring. Now we will solve this particular scenario having the module intact. Since the power pins are no longer available, we can multiplex the wiper pins of the 2 potentiometer. Here, we are cutting off the signal pins of one potentiometer and reading the other one's value and vice versa. We will use the digital pins D3 and D4 to switch on and off those 2 transistors, thus allowing only one wiper pin to be exposed to the A0 pin at a time. Finally, simultaneous reading can be accomplished by maintaining a short delay between those consecutive switching. Let's see how we implemented the idea in Arduino IDE. The very first part deals with the LCD display, which is not the topic of today's video. You can also print those values to the serial monitor. In the following part, I have defined S1 and S2 as 2 switching pins. In the latter section, the pin mode selection, and then we are setting both S1 and S2 to low in the setup. There's 2 variables var X and var Y for the X-axis and Y-axis potentiometer. Then we are setting S1 to low and S2 to high, thus allowing X-axis potentiometer's wiper pin to send analog output to A0 pin. Then this value is printed to the LCD display. In the latter part, we turned S1 to high and S2 to low, allowing the wiper pin of the Y-axis potentiometer to send its reading. This value is also printed in the second row of the LCD display. Note that we had a very short delay of 10 milliseconds between reading of the 2 potentiometers value. And this gap is also so small that the whole process seems simultaneous. Now let's see the practical implementation of the joystick module problem. Notice that after implementing the idea we discussed, we are now able to get the X and Y axis value separately. The number of sensors can be increased as long as we have available digital output pins. I hope you have enjoyed the tutorial, and if you do so, please like and subscribe the channel. Let me know about your idea of multiplexing without using a multiplexer in the comments. Thank you for watching.